Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. I really want you to pay attention today because we have a man with us who has been with GE for over 40 years. He's a physicist. He has a company called Low Blue Lights at lowbluelights.com, which is a spin-off of a company called Photonic Developments, LLC, its parent. And the Lighting Innovations Institute, which is housed at the John Carroll University in Cleveland, Ohio. And we've invited Richard Hansler today, who is also the author of Great Sleep, Reduced Cancer, a scientific approach to great sleep and reduced risk of cancer, and Heroes of Cancer Prevention Research, how scientists are discovering the environmental factors in modern society that increase the incidence of cancer and how to overcome them. I have to tell you that these two books I've read, and they are way more than just about cancer. They are about optimal health and wellness and disease prevention. And we're going to talk today about how modern lighting has altered our biology and physiology, has brought about much more disease, and what we can do about it. And it has to do with the circadian rhythm and the pathway to producing melatonin and much more. Ladies and gentlemen, welcome Richard Hansler to It's Rainmaking Time. Good morning.
Good morning. Thank you, Kim.
First, I want to congratulate you on a fantastic job with you and your partners and your team in developing some marvelous products, which I am using, by the way. I really love them, and they really work. They really are scientific. But I really want you to share about your background and how you came to recognize that lighting has a scientific effect, either good or bad.
Well, when I was at GE Lighting, I was doing research on how to make better and brighter light bulbs. And at that time, we certainly were interested in how the light affected people. We had people in our staff that looked at schools, for example, and studied how better lighting helped students learn more quickly. And we studied how UV light helps to make vitamin D when the sun shines on you, and we developed lights that produced UV that stimulated the production of vitamin D. But I don't think any of us at that time were aware that light has even more profound effect than that in terms of its effect on people's health. And it wasn't until after I retired from GE and came to John Carroll that I began studying the effect of light on human health, and was somewhat chagrined to find that, to my surprise, light can, when used at the wrong time of day, can be very detrimental to health.
Why don't we start with just giving a baseline to the audience? Because I would say most of the people listening are going to be using tablets and cell phones, smartphones, the computers day and night. People barely can sit and talk together at a restaurant without being on their smartphone. So we're glued to these tablets. And I want you to talk about what the circadian rhythm is and what parts of the body are responding to that rhythm and how this relates to what your findings are.
Well, the way that light affects the human body when used at night requires an understanding of some newly discovered sensors in the eye. It wasn't until 2001 that this was discovered, that there are sensors in the retina of your eye that have nothing to do with vision. We know about the rods and the cones that are responsible for the color vision that we have and how wonderful they are. But it was discovered that there's a third type of sensor called a ganglion cell sensor that is located in a slightly different layer of the retina, and it responds to primarily to blue light. And the nerves from those ganglion cell sensors don't go to the visual cortex part of the brain that's responsible for vision, but rather go to the so-called, it's one of those fancy words, that we abbreviate SCN, that is at the center of the brain, that controls the circadian rhythm. It's the clock, the internal clock, or biological clock, or circadian clock. Those are synonyms for this device that actually works as a clock. It keeps track of time, and the way that works is under study by hundreds of people throughout the world. It's a very complex operation, but we don't have to get into all that part of it. All we have to know is that internal clock is what controls the production of melatonin by the pineal gland. And again, that's a highly complex process, not fully understood, I'm sure, but we do know enough about it to realize that melatonin takes the information from the clock and distributes that information throughout the body. When the internal clock tells the pineal gland to produce melatonin, it does so during the night. And that's why melatonin is called a sleep hormone, because it's produced primarily during the night. And it starts with a slow flow at maybe 8 or 9 o'clock in the evening, builds up to a maximum about 2, 3 o'clock in the morning, and drops back to near zero about the time that we wake up. And during the day, the pineal gland does not produce very much melatonin at all. It's barely detectable. So the circadian clock is reset every day by light. And that's the thing that was not understood until the turn of the century, until 2001, that the special sensors that I talked about in the eye that produce the signal that goes to the biological clock, it resets that clock every morning, and a certain number of hours later, the clock tells the pineal gland to start making melatonin. But the hitch is that it only will start making melatonin if the body is in darkness. That is, if the sensors are not seeing light. If they're seeing light, it stops the production of melatonin. And that's why when you use your iPad or your iPhone in bed at 11 o'clock at night and you wonder why you can't sleep after a while, it's because the light from the screen of your device has shut off the flow of melatonin, or at least reduced the amount. So that's why we are beginning to understand now how light is having such a big impact on our health. It's this process of shutting off the flow of melatonin when one uses light in the evening.
Is it true that not only it shuts off melatonin, but does it stimulate cortisol?
Yes, the production of cortisol is also controlled by the pineal gland through the flow of melatonin. It's again a little complicated, but it's the signal from the internal clock that controls cortisol as well as melatonin. And melatonin is the communicator that tells the gland that produces cortisol to make it at the time of day that it does.
So for people that are awakening at between 2 and 4 in the morning that don't want to be awakened and they can't seem to get back to sleep, but they're awakened pretty viscerally, what do you suggest for those people?
Well, we know that by maximizing melatonin, that the body tends to stay asleep better than if you don't maximize the melatonin. In other words, if you start making melatonin earlier in the evening and let it come to its full maximum during the night, that will help you stay asleep. our customers tell us that not only helps them fall asleep, but it also helps them stay asleep.
Well, I want you to know that I've been testing your glasses and using this little light, when you get up in the night to go to the bathroom so you don't turn on the bright lights. And it really works. I'm shocked. And I find myself falling asleep earlier.
Well, we have many people that are skeptical when they buy the glasses that, how can just wearing a pair of glasses help me sleep better? And we get the same story over and over again that people are surprised that they really work.
What is it about the spectrum of blue lighting that's the big deal? Why is it blue lighting that we're trying to lower?
Well, this was the study that I talked about that was reported in 2001. There were actually two groups, one at the Thomas Jefferson University in Philadelphia, Dr. Brainerd, and another group at the University of Surrey in the United Kingdom. Both groups were studying the effect of light on the production of melatonin, and they did it by exposing people to monochromatic light of just one color, and for like an hour or two in the middle of the night, and then measured how much melatonin was being produced. And they did this, Dr. Brainerd took him more than 5 years of experimentation to determine that, in fact, it was primarily the blue light that was most effective in suppressing the production of melatonin. And the group in Surrey found exactly the same result. And both groups reported on the same date in August of 2001. And so unfortunately, they agreed with each other. It was the peak of the curve is at about 480 nanometers in the blue part of the spectrum.
Oh, interesting. Talk a little bit about people that work at night on swing shifts or people that are working in hospitals under hospital lighting and the effects on their bodies, what they're actually putting themselves through and what they can do about it.
Well, this is one of the areas where the early studies showed that people that do work night shift have a higher incidence of cancer, breast cancer in particular. There's a famous study that goes on continuously called the Nurses' Health Study. It's run out of Harvard University, Harvard Medical School, actually, and it's been going on for, I think, almost 50 years now. And every year, nurses that are part of this program report in great detail about their health and their habits and how much sleep they get and what they eat and all of that. And Dr. Schernhammer comes from Germany, and several of her acquaintances were nurses who worked shifts, and they developed breast cancer. So that when she came to Harvard, that was on her mind, and she became aware of this Nurses' Health Study and went through looking at how many hours of overtime or night shift work various nurses had done, and then looked how many of them developed breast cancer. And to her surprise, maybe not complete surprise, but what she found was that the nurses that had worked night shift for many years had about double the incidence of breast cancer as nurses who had not worked night shift. And that was a very important finding, and it confirmed studies that had been done with animals. Animals that were exposed to light during the night so that it suppressed their melatonin were much more likely to develop cancer, breast cancer, when given a carcinogen. There was one study in which they looked at the incidence of breast cancer in mice, where the mice, when the mice were given a carcinogen, one group were housed under 14 hours of darkness, where they made lots of melatonin, and another group was housed under what we call short short nights, 8 hours of darkness like we get. And the ones that were in the short darkness developed many more cancers than the group that was housed under the long nights of 14 hours of darkness. That was the only difference between the two groups, was the amount of time they spent in darkness. And the ones that were in darkness the longest had a much reduced rate of cancer as a result of an injection of a carcinogen.
I have a question about the glasses. What's the difference between the glasses that your company has made versus other companies that are saying they're blocking out blue light? What is the main distinction?
Well, we certify our glasses as blocking the part of the spectrum that is known to produce the suppression of melatonin. Our glasses block all of the light at a wavelength shorter than 530 nanometers, which is in the blue-green part of the spectrum. Glasses that one can get from other sources, some of them may block that same region. Many of them not only block the light at wavelengths in the blue, but also block a lot of the light in other parts of the spectrum. Our glasses only block the blue and let all of the other light go through. That means people can wear them and carry on normal evening activities like watching TV or running a computer or whatever without too much interference. The major change in watching television is that if you're watching tennis, for example, it's being played on a blue court. If you put on the glasses, it'll make it look like a green court. But otherwise, the other colors are all reproduced in normal fashion.
I want to talk a little bit with you about the medical community. These are your words. How the media demand clinical trials to reveal the truth rather than just simply seeing how it works and noticing that it does work and looking at the results.
Well, I don't fault the medical community too much. It's basically a good premise. But in a case like ours, where we're talking about a material, about glasses that are worn as a way of improving your health, naturally they're skeptical to start with. And unfortunately, we don't have enough business that we can afford to do a clinical trial. We did do a small study of the effect on light, in which we did a double-blind study. One of our students here at John Carroll University was a senior the year we came up with her glasses. She got interested in it. She's a biology major. And she did a small study of our glasses compared to placebo glasses, and found that, in fact, for the small group of people that she worked with, that they did, in fact, improve the time to fall asleep and the depth of sleep, the quality of sleep, and also improved mood. Those results have been published in a journal in 2007, I think it was. Her name is Kim Burkhardt, and if you go to the journals, you can find a write-up of her results. But that was a very small study. I've approached Harvard people, Dr. Lockley, about doing a study of our glasses, and he said for $200,000 they'd be happy to do it. But unfortunately, we don't have that kind of money.
In the meantime, though, what's neat about what you have done is that people can start using what you've produced and see their own results. They don't have to wait for clinical trials on something that already works.
Right. That's our feeling, is that, and we were going to do a study here at John Carroll. We made a proposal, and unfortunately, the internal review committee turned it down. They said that our method of studying the effect of the glasses was not sufficiently scientific, we had only asked whether they worked or not, and what they want us to do is to wire up people in a sleep lab, and that's the kind of thing that costs $200,000.
Unbelievable. Well, it is what it is. They have a lot of interest that they have to protect. I'm sure
Well,
it's,
the way we protect our customers, we're interested in helping. When you're as old as I am, you're not too interested in making money anymore. And what we're really interested in is helping people sleep better and improve their health. And we offer a guarantee if our glasses don't help them sleep better, we'll be happy to refund the money. Our glasses are available on the website at lowbluelights.com. And again, we offer a guarantee that if they don't help them sleep better, we're happy to refund the money.
I think that's fantastic. I want to talk a moment with you about postpartum depression.
That is an area where we have done a study. We funded that ourselves, and it was, again, a double-blind study using placebo glasses. There's a doctor on the West Coast that we worked with who has written a book on the subject of Dr. Bennett, who has written a couple of books about postpartum depression. She had it herself each time she had a child and suffered mightily with it. It stimulated her to get a degree in psychology and now counsels with women that have postpartum depression. Anyway, with her help, we did a study of about 30 women who had postpartum depression. We gave them either placebo glasses that don't block the blue light or our regular glasses that do block it, and then observed for a period of time how rapidly they recovered. And the women that were using the real glasses recovered more quickly than the ones that were using the placebo glasses. That, again, was written up as a preliminary study and is published in Medical Hypotheses.
The pineal gland obviously is a bigger player than we even imagined, even though it's very, very small, isn't it?
Right. Because it conveys the information about darkness throughout the body, there are actually all of the organs in the body and the brain and tissues throughout the body have what are called melatonin sensors. And when the amount of melatonin in the body increases, it tells all of the glands and organs and tissues that it's nighttime, time to rest and recuperate. The body temperature falls, and the body has a chance to recover and rebuild. And by exposing our eyes to light during the evening, when we normally would be making melatonin if we were under the conditions we had when we evolved, we would have our bodies more rested by the time morning comes. Another side effect that I should mention that many women during the winter suffer from what they call SAD, seasonal affective disorder, in which they feel down in the dumps or depressed in the morning. And they don't have this problem during the summer when there's lots of light around, but only in the winter when there's relatively little light. And down in Australia, they have, of course, the reverse. They get depressed during their time of winter. Anyhow, by starting the flow of melatonin earlier in the evening by the use of our glasses, say you put them on at 7 or 8 o'clock, you start the flow of melatonin. By the time you wake up in the morning at 7 o'clock in the morning, the body is finished with its flow of melatonin. And by doing this, it turns out that the body, you avoid the problem of feeling depressed. the reason that the women are feeling depressed in the wintertime is that their bodies have too much melatonin in the morning, and they therefore, because they're exposing their eyes to light during the evening, it doesn't start soon enough, and therefore it doesn't end soon enough. And that's borne out by the fact that the traditional treatment for SAD is exposing the eyes to light in the morning. And again, it's found that blue light is more effective than ordinary light, so that now the standard method of treating SAD is to expose the person that's suffering to blue light when they get up in the morning for about a half an hour or so. So it's all part of the same story. It's just the other side of the coin, if you want to think of it that way.
I used to take melatonin some years ago, and it woke me up in the middle of the night every night, so I stopped taking it. I didn't know why it did that, but it woke me up. I could never sleep through the night when I took melatonin. I guess it was 3 grams or whatever.
Taking melatonin by mouth can help one fall asleep. No question about that, and it's useful during jetting around the world. People find that it does help them to readjust their circadian rhythm. But we think that our glasses are a better way to do it. And the trouble with melatonin taken by mouth is that it has a very short half-life. It only lasts for about 4 hours. Now, they've come out with a form of melatonin that's called slow release.
Yeah, time released.
And that does work better. But again, we think it's better to use to maximize one's internally produced or endogenous melatonin rather than to take a pill.
When people get up in the middle of the night to go to the bathroom, how much light needs to enter their eyes to disrupt melatonin's production?
Well, there's been a continual drop in the estimate of how much light it takes to suppress melatonin. When they first started treating SAD, they used banks of fluorescent lights that made like 10,000 lux. But now it's found that even the light from a iPad is enough to suppress melatonin. There's a recent study at Rensselaer in which they found that 2 hours of use by a young person of an iPad, a group of young people, reduced melatonin by an average of 23%. The amount that's required is pretty small. There have been other studies recently at Harvard, Dr. Lockley, and also again at the University of Surrey. There was a study done that was funded by Philips Lighting, which is the world's largest maker of light bulbs, in which they found that light such as one has in one's normally lighted living room is enough to significantly suppress the production of melatonin. They did quantitative studies, and the report is really quite a condemnation of the lighting industry, in a sense that despite that Philips was paying for it, the results were pretty negative as far as the use of ordinary light bulbs.
How long did it take you to develop these products for people? From the time you thought about it till having them ready for the market? I'm just curious as a business person.
Well, it didn't take all that long. It was a matter of developing the techniques for the coating of the bulbs and the identifying of glasses that had the right characteristics. So the developing of the light bulbs took a little longer. We started out doing primarily incandescent lamps, and were able to locate vendors that made coatings that were suitable for the purpose. And then a little later, maybe 6 months later, we were able to identify some makers of compact fluorescent lights that had the right spectrum. The glasses, again, it was a matter of identifying people that had the right color. We were in business after a period of about 6 or 8 months, I think.
Wow, that's fast.
It was fast.
When something's ready, it happens fast.
We felt an urgency about getting something out there when we knew that people were being harmed by these beautifully bright light bulbs that I had developed at GE. I have sort of a feeling of guilt about the bad effects of ordinary lighting.
Well, you're going to transform that guilt because look at what you've done. You know what's very interesting, even before I got to the part of the books about what babies go through, this whole area of like newborns and babies being in 24 hours of white light. Talk about what it does besides suppressing their melatonin. Doesn't it do something else to them?
Well, the effect of light on preemies has been studied quite a bit because there's a lot of concern about blindness. There were many babies that were born prematurely that ended up being blind, and that, in fact, was not related to the light, but rather to the use of excessive oxygen. But certainly the report of parents of preemies is that when they bring them home, they have terrible sleeping problems. And it's thought to be related to the fact that they don't develop a circadian rhythm properly when they're exposed to light 24 hours a day in their incubators. Some hospitals are beginning to take note of that and are shutting off the lights part of the 24 hours in order to begin to develop a 24-hour clock that works properly.
Bravo to them. I think it should become a standard. Really?
Yeah, I think it will become standard because there's more and more understanding of the importance of the circadian clock. In fact, one of the interesting things that's been known for many years is that in the treatment of cancer, when chemotherapy is done at different times of day, that it makes a big difference in how well it works. And what they found is if it's given during the night when the body has melatonin present, that it is more effective and there are fewer side effects. So that they call this chronotherapy, where chronos from the word clock means that they take account of the fact that the body does go through these different stages and that the effective treatment is much better if you do it in synchrony with the body rather than opposing it.
Are there tests to check your melatonin, and are they effective?
It's possible to test the melatonin. You have to ask your doctor to do that test. It's a fairly expensive test, and that's one of the impediments to doing these studies, is that it costs a lot of money to monitor the melatonin production.
Richard, what about, for example, in California, it's dark now at 5 p.m. So when it's dark at 5 p.m., people are still driving, they're coming home from work. But if you're home already, what do? We're putting on the glasses then, or are we waiting a few hours? There's a gap between it's dark at 5 versus when to start the melatonin.
Right. Well, on average, of course, during the time that all of us evolved, or whatever we did, over a period of millions of years, we were in darkness on average of 12 hours every night. And now during the winter, we're in darkness more than that, and then summer less than that. But the body is still functions best on a 12-hour dark, 12-hour light schedule. And so that, again, the ideal would be to try to duplicate that as much as possible. And since our glasses create the equivalent of darkness, we recommend that the total time that you're in darkness should be adjusted to the 12 hours that we enjoyed when we evolved or when we developed. And by putting on the glasses, say at 3 hours before bedtime or 4 hours before, and sleeping 8 or 9 hours, one will be where you actually sleep in darkness, which we recommend. Your total melatonin production will approach the 12 hours that's known to be possible.
Would you say that many people don't sleep in enough darkness?
Yes, that's a very common problem. A lot of people sleep with a TV on, or they sleep with a clock that's putting out blue light. And we recommend that try to extinguish as much as possible, make the room as dark as is convenient. Some people have to put up blackout shades to keep out the street lights from shining in their windows.
Let's talk a little bit about jet lag, because a lot of people who listen travel. Talk a little bit about blue lights, jet lag, and what you recommend for people who are traveling. Let's say there are people traveling to Europe. There's going west and there's going east, and apparently it's different, right?
Right. If you're going east, it's a little easier because what we recommend is that you put on the glasses about an hour earlier each night for about 4 or 5 nights in advance of when you're leaving. That way it'll move your circadian rhythm forward in time so that when you get to Europe, you'll be in sync with the local time there. Moving an hour a day is about a little bit more than the body does easily. The body does only about 15 minutes a day easily. So if you want to start a couple of weeks ahead of time and move it ahead 15 minutes a night, that will work better than trying to move it an hour a day for 5 days.
And going not to Europe, but let's say to the Far East.
There you would, of course, want to put the glasses on in the morning in order to try and extend the day that way and go to bed an hour later each night. Put on the glasses an hour later until again, you don't have to change your sleep schedule. All you have to do is change your exposure to light schedule. By using the glasses, by using ordinary white light in the evening to delay your production of melatonin, and putting on the glasses in the morning to continue the delay, you can adjust for going west.
You have how many partners here?
3 partners in our company, actually, yes.
Right. There's Edward Carome, Dr. Carome.
Right.
And Dr. Kubulins?
Yes, Kubulins and Dr. Alpert.
And Dr. Alpert.
Dr. Alpert is actually a medical doctor. The rest of us are physicists.
Wow. This is really exciting. So tell us what you think are the greatest challenges right now for this information and this new knowledge to get out. What do you think it is?
Well, it's difficult to get people educated about matters like this. If you don't have a sleeping problem, you're probably not going to be too interested in the whole subject. And that's unfortunate because the health effects, we think, are, more significant than the sleep effects. Now, sleep affects health itself, so getting better sleep is certainly a goal in itself. But the effect of light on cancer and on other health issues are, I think, even more important. If all women would start using our products, I think we could actually cut the breast cancer rate in half. The reason I say that is that studies of blind women who make melatonin to the maximum have only an incidence of about 50% of women with normal vision, which is a remarkable figure in itself. And that's been verified by not only studies in this country, but by studies in Europe as well. And one of the sidelights, Dr. Scharnhammer, that I mentioned earlier, that did the nurses' health study, got interested in the fact that blind women have a lower incidence of breast cancer. And the thing that she noted was that there are really 2 types of blind women. There are blind women that are totally blind, that the light does not control their circadian rhythm. And there are other types of blind women who don't have no vision, but whose bodies are still able to detect the blue light and control their circadian clock, and therefore she looked at the incidence of cancer in these two different types of blind women and found the ones that were totally blind, again, had about half the rate of breast cancer as the ones that still had the ability to control their circadian rhythm. That was a very interesting study, I thought.
Wow, that is interesting. What about macular degeneration and cataracts? What does light have to do?
Macular degeneration is known to be the result, partly the result of exposure to blue light. The individual photons that make up blue light carry a bigger energy impact when they are absorbed in the retina, and they can do chemical damage to the retina if their exposure is too intense over too many years. People that are diagnosed with beginning macular degeneration are prescribed glasses that block blue light. Usually it's a little bit too late at that point. I recommend that people protect their eyes from blue light normally by the use of sunglasses, and most sunglasses not only block blue light but also other colors as well.
But sunglasses are different than the glasses that you've produced.
Right. There are blue blocker sunglasses that do block all of the blue light, and but also block some of the other wavelengths. And those are the type that I would recommend for people that are concerned about macular degeneration. We don't recommend that people use our glasses as sunglasses. They're simply not dark enough.
I know an 80-year-old woman, very smart woman, but she can't sleep, so she has lights on all night long. And
that's probably why she can't sleep. I don't know which came first.
Yeah.
Certainly, having your lights on all night long would certainly not be a good plan.
They say after 50 years of age, both men and women don't make the hormones that they used to, and therefore a lot of people, until they can get those hormones balanced, have sleeping problems. Have you found men have gone through their change and women have gone through their change of life who started using not only the glasses that you produced, but also the night lights and the little flashlights that get blue light out of the spectrum?
Well, we have not studied the effect of menopause primarily because we're just not medical people. We're
right.
more able to study the effect of light directly on the body, and the effect of the lack of estrogen is one of the reasons that women have hot flashes and so on. It's primarily due to the fact that the ovaries stop making estrogen. There's a technique to add estrogens to replace that, but you do that in peril because it's more than likely the effect of melatonin on blocking the cancer-stimulating effect of estrogen that it works as well as it does for blind women, for example, or for people wearing our glasses. But after menopause, by adding estrogen, one increases the risk of cancer, and that was demonstrated in a very large health study that was initiated by the government really through the NIH, the National Institutes of Health. They instituted a very large study of taking supplemental hormones after menopause.
Well, they've been wrong for about 40 years, unfortunately for them. And unfortunately, Richard, they never distinguished between apples and oranges. They never talked about the kind of estrogen, because the kind of estrogen that is delivered and brought into the body, if it's not biologically like the body, they were using horse urine on women. So you really have to compare apples to apples and oranges to oranges. The study, I know what you're talking about, I would say is a flawed study. And it's the basis of the fight that the medical establishment has had with the alternative health establishment with respect to the hormones. But I do know what you're talking about.
Right. Well, we think that if one adds estrogen after menopause to avoid the symptoms, if one also maximizes melatonin, the risk of having the supplemental hormones causing a problem is greatly reduced because of the ability of melatonin to blunt the cancer-causing abilities of estrogen.
You know, they used to tell guys, don't take testosterone because you'll get cancer. And then they found out in the last 10 years that many of the men get prostate cancer because they've had their testosterone dropped to such an extent. My father was one of them.
Uh-huh.
And women have been told the same misinformation. The devil in the light is always in the details on this. But I think it's fascinating that you're talking about the melatonin quotient of this and the contribution of melatonin.
Talking about prostate cancer, again, shift workers have been found to have a higher incidence of prostate cancer. And again, it's thought to be the fact that they don't produce as much melatonin. So that maximizing melatonin for men is also beneficial in reducing that risk.
That's exciting. Where can people go? People are going to go to lowbluelights.com and they can order night lights, iPhone blue blocking filters. I wonder how that works. Is it something that kind of straps on the iPhone or an iPad, or is it something you have to stick on?
It's a new product that we just announced last week, and it adheres it's a thin film. It blocks the blue light, and it adheres very tightly to the surface. You simply put it in place and then squeeze out the air bubbles, and it'll stay there. It adheres very tightly to the surface.
Won't tablets look funny? Because it'll make everything look orange, won't it?
Slightly. It's not as orange as our glasses.
Okay.
And so that the color effect is reduced, but the operation of the device is not influenced at all. You can still do the touch screen things without any interference.
I love the flashlight that you guys created. That is really cool, too.
The little flashlight uses, and our night lights use what are called amber LEDs, so that the emission of those LEDs is very far removed from the part of the spectrum that causes any problem with melatonin, so that we're very sure that they are perfectly safe.
Fantastic. Well, Richard, I want to thank you for all that you and your partners are doing at lowbluelights.com. We're excited about your work and your product line. And for all of you listening, you should pick up Richard's books, Great Sleep, Reduced Cancer, A Scientific Approach to Great Sleep and Reduced Risk of Cancer, and Heroes of Cancer Prevention Research, and know that it's more than just about cancer. It's about optimizing your health and well-being. And thank you so much for being with us, Richard.
Thank you for the opportunity, Kim. As I said, I feel a debt to society that I worked for so many years making better and brighter light bulbs, only to find that they were in fact killing people, and I felt that I had to do something about it. So that's what our website is about. It's really helping people.
Thank you so much.